then the drum is trash. Check the pocket where the total in-play thrust washer and Torrington bearing sits. Inspect the input shaft where the bushings ride. Inspect the splines at the end of the turbine shaft. Inspect the end of the shaft where the torque converter clutch seals. This area of the shaft will apple core if the lockup clutch fails in the torque converter. Check the lockup accumulator check ball. It should be free in the orifice. Now the input drum and shaft will separate the same way the stator and support did, and is serviceable apart from each other. Usually when you buy these parts, they will come pressed together. Check the clutch drum teeth and snap ring grooves. Check the 3/4 oil release check ball. It should be loose and rattle in its orifice. Inspect this end of the shaft for any wear, and the top of the tower where the Torrington bearing sits. Now let's inspect the gear train part of the transmission. We'll start with the top and bottom planetaries. Now check each pinion gear for side-to-side movement. If there is any movement at all, then that gear is bad, and the whole planetary carrier will need to be replaced. Look for any pitted or chipped teeth on each pinion gear. Now inspect the entire body of the planetary carrier for any damage. This particular carrier is bad on both ends, top and bottom. Inspect the Torrington bearing that lays in the bottom of the carrier. Now the bearing in the bottom planetary will move around a little in the carrier body. That's okay. The rear sun gear will stabilize it once the transmission is together. However, the bearing in the top planet should not move side to side and sets tight in the carrier. Ensure the splines are in good condition. If all the gears are in good shape, then check for up and down movement. Slide a filler gauge between the planet's gear washer and the gear. The pinion gear in play should be 8 to 24 thousandths or 20 to 61 millimeters. Check the top and bottom sun gears for any chips or pitting. If you need to replace the bottom sun gear, don't forget to swap the snap ring to the new one. Inspect both top and bottom ring gears. Check for metal embedded between the teeth. Inspect the outside of the top ring gear where the 3/4 clutch is splined to. Check the top hub for any damage done by the 4-tang thrust washer. Inspect the splines toward the end of the hub. Check the outside bushing surface. Inspect the 2 bushings inside the hub. And of course the hub shaft should not separate from its base. Now let's inspect the input sprag. Check the hub for any cracks or any damage that might have been done by the overrun friction plates. Inspect the inner race where the sprag element rides. Now it needs to be completely flat with no grooves at all. This inner race has grooves and is badly worn and needs to be replaced. Also check the inner race for grooves. If it has any, then it's trash. To check the low and reverse sprag and support assembly, inspect the support where the low and reverse clutches make contact. Check it the same way you did on the pressure plate and steels. Check the inner race for any grooves. This race is bad and needs to be replaced. And of course, if your support and sprag assembly is in this condition, then of course it's totally trashed, and you will need to purchase the whole assembly. If it is in good condition, then you will need to remove and inspect the low and reverse sprag element. Remove this snap ring. There's one on each side. Remove the element. Be careful, it's very fragile. Inspect the sprag by giving it a small shake. If any of the rollers or accordion springs fall out of the cage, then the sprag element is bad and you will need to purchase a new one. Check the ramps on the outside of the cage. They should look exactly like this one shown here. Inspect the ramps and the support for any cracks. Now, witness marks where the rollers make contact with the support is okay as long as there is no pitting or bad metal porosity. If everything checks out okay, then reinstall the sprag element, matching the ramps together. This is what it looks like properly installed. Reinstall the snap ring. Install the inner race into the sprag with the clutch side of the support facing down. Turning the inner race clockwise will help when installing the inner race. With the clutch side of the support facing down, the inner race must turn clockwise only. Now let's examine the sun shell. A common problem with this trans is the spline section separating from the shell, or the splines themselves will be completely stripped out. When this happens, you will lose second, fourth, and reverse. There is an aftermarket design. It's thicker and has more metal at the breakage points. It's named the Beast, and I highly suggest you replace yours with it. That is, if you want to keep second, fourth, and reverse for a while. Now, moving on to the output shaft, examine the areas where the bushings ride. Inspect the splines. To inspect the servo assembly, inspect each piece for any cracks or bad porosity. To separate the servo's inner parts, remove this E-clip. Once the E-clip is removed, then remove this snap ring on the opposite side. Take caution when removing this snap ring. There is a strong spring behind this cover. To reassemble, simply reverse these steps. Now examine the spacer plate where the 1/4-inch steel check balls beat against the plate. You're looking for any holes that are egg-shaped or have any raised edges, like this one here. This plate is trash and needs replacing. Now inspect the second accumulator housing for any grooves. The surface must be completely smooth. Check the pin for apple coring. Check the piston pin bore for side-to-side movement. Check the ring land for any damage. Examine the entire transmission case for any metal fatigue, cracks, or bad porosity. Inspect the lineup holes for any egg shaping. Inspect all the threads throughout the case. Inspect the 4th accumulator bore. Inspect the guide pin hole for any egg shaping. Ensure that the cup plug is in place. Inspect the 2/4 servo's apply pin hole. Check the servo bore where the sealing rings ride for any damage. Examine the 3rd accumulator capsule and ball. The steel ball should not fall out but move free in the capsule. Ensure that the cup plug is in place. Now let's move on to the electrical part of the transmission. Now inspect the entire wiring harness for any cracks. If you see any damage at all throughout the harness, then replace it. Believe me, the last thing you want is electrical problems. Check all of the connectors, making sure they still have their locking tabs. To check the electrical part of the solenoids, you will need a multitask ohm meter. Measuring across the terminals on both shift solenoids A and B, their resistance should be 20 to 40 ohms when measured at 20 degrees Celsius or 68 degrees Fahrenheit. Hitting the solenoid with 7.5 to 12 volts DC, the solenoid should energize. If your transmission uses the late TCC PWM solenoid, then it should ohm between 10 to 15. The 3-2 control solenoid with the late white plastic stem connector must have a resistance between 20 and 31 ohms. The early style 3-2 solenoid will have a gray connector and should ohm between 10 and 15. The pressure control solenoid, or force motor, its resistance should measure 3.5 to 4.6 ohms. The lockup solenoid measures between 20 and 40 ohms. The late style lockup solenoid will have a thimble screen locked in the snout. To remove it, use a pair of needle nose pliers and turning the body of the screen clockwise, remove the screen. To install it, simply reverse the process. Next, inspect the pressure manifold switch. Inspect the temperature sensor in the switch, making sure its leads is still soldered to the terminals. Examine the 5 pressure switches and the body for any warpage or cracks. If any of the 5 switches show any signs of deteriorating, then the manifold is bad and you will need to replace it. Well, that wraps up the inspection. Now let's replace that bushing at the end of the stator. To replace bushings, you will need a bushing driver set similar to this. It is important that you select the correct size bushing driver that fits the bushing you're working with. First, you will need to measure the distance from the top of the stator to the top edge of the old bushing. You can use any method to measure this distance, but to achieve the best measurement, use precision calipers. Setting the caliper on top of the stator, measure and record the distance. Then remove the old bushing. Using the chisel method, cave the bushing in, folding it down away from the inside edge of the stator housing. Never use this method when removing the pump bushing. Always use the correct size bushing driver to remove the old pump bushing. During the rebuilding process, we will replace the pump and transmission case bushing. Now select the correct size driver that fits the new bushing. Drive the new bushing in, stopping to check the distance you recorded from the old bushing. Stop when you have achieved that measurement. Next, slide the part through the bushing that mates to the bushing you've just replaced, which in this case, the stator over the input shaft. Then using a dead blow hammer, strike the outside of the stator housing while spinning the stator around the input shaft. This action will seat the bushing and get rid of any rolled edges that may have been caused by the bushing driver. Next, separate the parts, clean and get rid of any loose material. Once this is done, then slide the parts together again. The parts should spin freely. It's a good idea to replace all the bushings throughout the entire transmission. If you don't feel comfortable replacing bushings, then take them either to a machine shop or a transmission shop. They perform this every day and shouldn't have any problem replacing all your bushings. To identify the different designs and makes of the rubber piston seals throughout the 4L60E transmission, I've cut them in half to demonstrate the difference. This is the lip seal. Notice the lip part of the seal. The lip always faces the fluid containment area. And the D-ring, it gets its name because it looks like the letter D. The square cut O-ring because it looks like a square, and the O-ring because it looks like an O. Pretty simple, huh? Never use gasoline or diesel to clean any of your transmission parts. The best two chemicals to use is either mineral spirits or cleaning solvent. Immediately after cleaning, blow the parts dry using compressed air. Never use carburetor cleaner to clean electrical parts. To clean the electrical, use either solvent or an electrical cleaner specially designed for electrical parts. Whichever method of cleaning you choose, always wear protective gloves designed for the chemicals you're using. Use a hand scraper to remove the O-gasket material. A small paint scraper works great for this. Be careful not to gouge or damage the part you're working on, and never use a die grinder, especially on the transmission case. Now you can hand wash all the parts, including the case, but the best method is to use a heated parts washer. Most machine shops, as well as transmission shops, will have this equipment, and for a small fee, may wash all of your transmission parts, including the case. The parts are loaded on a parts tray. Notice the small parts basket. This is used to clean the bolts and plastic washers. Wash the molded pistons in solvent only. The Torrington bearings and valve body parts, wash them by hand. Never use a heated parts washer to clean electrical parts or the valve body. For those stubborn gaskets that have baked themselves to the parts, the heated soap and water used in the washer will soften the gaskets and make that scraping job a whole lot easier. The parts should cycle about 60 to 30 minutes. Once the cycle is complete, then the parts are air dried using compressed air. And that old gasket, it just falls off. Always clean the oil lubing holes bored through the output shaft. To help remove any blockage, push air through the hole at the end of the shaft. Then the case and pan is set in the cabinet, bell housing down. A straight bar is used to stabilize the transmission case during the cleaning cycle. The case is dried with compressed air. All passages should be hit with air to remove any restrictions or blockages. Lightly sand the valve body area of the case to remove any raised edges or bits of gasket material. Use 400 to 320 grit sandpaper. Then give the case a final wash. To clean the valve body, use carburetor cleaner or submerge the valve body in solvent, and use air to help remove the foreign material deep in the webbing and in between the valves. Clean the wiring harness using solvent or electrical cleaner. Use light air when drying the harness. Don't forget to clean the snout at the end of the lockup solenoid and remove any restrictions. Clean all the electrical components. When cleaning the pressure manifold switch, use very light air and handle the switch with care. You don't want to lose any of the O-rings or the switch pads or damage the temp sensor. Using Scotch-Brite, knock off the cylinder glaze on the second and fourth accumulators. Move the Scotch-Brite around the bore in this direction only, then re-clean. Last, knock the glaze off the 3/4 and forward steels, laying them flat against a concrete surface. Using a circular pattern, rough up both sides of the steels. Do this on all the 3/4 and forward steels only. Do not rough up the reverse, overruns, or the low and reverse steels. And that's it for the cleaning process. Now let's put this transmission back together. Now, to put your transmission back together, you will need to purchase a master overhaul kit, much like the one we've put together here. The basic kit will have all your lip seals, O-rings, and the metal-clad seals, as well as all the gaskets needed to get your transmission back together and on the road again. It will also have all the friction plates and steels, or you can buy the steels separately from the kit, as we did here. Always replace the 2/4 band when rebuilding the 4L60E transmission. Notice the new bushings and filter. And always replace the input sprag with a new one. We'll start the rebuilding process with the rebuilding of the subsections. And we'll start with the valve body. Now, the valves are held in the valve body by retaining clips and roll pins. You will need to check the movement of the valves to make sure they are free in their bores. Most of the valves are under spring tension. To do this, use a small screwdriver or one of your picks. Now move the valve back against their spring pressure. Releasing them, you should get a pop as the valves move back into position. If not, then the valve is stuck and it will need servicing. First, remove the complete valve lineup. So not to get the valve lineup and their parts mismatched, service only one lineup at a time. Taking each valve, run your thumbnail across the edge of each valve land to find the damage points. You will need to purchase a package of heavy-duty Scotch-Brite. Run the Scotch-Brite around the damage points on the valves until the surface is smooth to the touch. Reinstall the valve lineup. Then, using a small hammer, wrap on the back side of the valve bore that housed the stuck valve. Use light taps here. You don't want to damage the valve body or collapse the bore. Now clean the valve body again and see if the valves move free. If not, repeat the entire process until